Okay, so now we're asked, we have kind of an interesting situation with a conductor here that has current coming out towards us, and then it's surrounded by a shell on the outside that has current going into page. So the net current would be 0 if you combined it all. They want to know the magnetic field due to this at a distance about 10 centimeters from the origin. So I'm going to say right there, since the whole distance is 15 centimeters to the edge of this. They want to know the magnetic field 10 centimeters. And I can use the symmetry of the problem to realize, if I could draw a circle anyway, that that oh boy, that's pretty bad. Anyway, if I had a constant radius at 10 centimeters, the magnetic field due to this current coming out would go around in a circle, and it would have the same magnitude everywhere along that if I had drawn it correctly. So then I can go ahead and use Ampere's law. It says the integral of B dot dl along a closed loop is just mu naught times the current enclosed by that loop. And so once again, I wish I had drawn things better, but I want to look at about that much current. So B dot dl, that's just going to be, B is constant around this loop, so it's just going to be that magnitude of the magnetic field that I'm interested in, and the circumference. So that's just 2 pi times r, the distance I'm at. It's equal to mu naught, which is a constant. Now I need to know how much current is enclosed. It's not the full 30 amps because I only have some of it shaded in. It's going to be proportional to the amount of area shaded versus the total area there. So it's going to be I total times, I'll just be pi times r squared, that's the shaded area, divided by the full wire cross section, which would be pi times a squared. If I solve this, I just get B is equal to mu naught over 2 pi. The pi's here canceled out. One of my r's canceled out, and I get a squared here. And that's my full answer. So now I just need to put some numbers in, and let me just do that for you just to make sure there's no mistakes there. So this is 4 pi times 10 to the minus 7th for mu naught. 2 pi is going to cancel out there. R is, this is 0.10 meters. That's where we want to know the magnetic field. And then A, we have a squared, and that's the radius of the inner conductor. So we square that and plug all the numbers in to get the answer.